copper ball, that's theta B1 is equal to 200 degrees Celsius. 200 degrees Celsius. That's it. Then we are told it's placed in copper calorimeter. So mass of copper calorimeter, call it MC, is given, it's containing, the mass of it is 60 grams. Containing water, they are also giving mass of water, M of W to become, to be 50 grams. Then initial temperature of water, initial temp, that's theta 1 W1, total for water, and that is equals to 30 degrees Celsius. Water is kept in copper calorimeter, so you expect initial temperature of copper calorimeter, theta Ci, to be 30. You know, you are taught last class that the temperature of the content will be the temperature of the container. We are giving temperature of water. The examiner or the question is silent about the temperature of the calorimeter. You ought to have known, a physics student, that temperature of the water will be the temperature of the container, because water is kept in the container. They will both have the same temperature. So that's why we take initial temperature of copper calorimeter to be 30 degrees Celsius. Now, we are also given specific heat capacity of water. The capacity of water, seawater, to be 4.2 joule per gram per Kelvin. That's it. We need the capacity of copper calorimeter to be given too. The capacity of copper calorimeter needs to be given. So if you are not giving, you can only work in terms of that. Take special capacity of its capacity of copper, that's CW, let it be 400, or because you are talking of joule, 4.0 joule per gram per Kelvin. You are not giving, but you can take it to be that.
Sir, I got 0.4.
You are not given in the question. You can work in terms of that. So if you give 0.4, whatever you are giving is what you are going to use. But because the question is silence about it, you can still work in terms of copper calorimeter. It should be 400 joule per kilogram per Kelvin. But if you divide by 1,000, you can have 0.4 joule per gram per Kelvin. But if in JAM, don't supply yourself anything. You work in terms of what you are given. And in such a situation, you will only claim that the option is not there. If you get an answer that is not in the option, you do that. But in WAEC or NECO, that you are solving theory, you work in terms of the special capacity you are not given. I hope I'm communicating.
Yes, sir.
Now, this question was taken from a textbook. It's an assumption because it's an exercise that you can really consult the textbook and bring out the specific capacity of copper because it's an exercise. But if it were to be exam, work in terms of that specific capacity of copper that is not given. I hope that is clear to everybody. Now, as it is now, we now want to, the first question I want to ask you is, a mixture of what do we have? How many things are mixed together here? Mixture of, who want to answer that? How many substances does the question mention here? When you want to say, you raise up your hand so that we can learn. How many substances are mixed together now? Yes? 3. Can you mention the 3?
Copper,
Louder, louder.
copper, water, and the copper can be water.
Can you hear her at the back? No. Who said no? How many substances are mixed together? You have the question throughout the weekend. Yes, how many substances are mixed together? Forget about what she said. 2. Can you mention those 2?
The copper ball and water.
Now, the girl that spoke earlier said 3, and that is very correct. So, the copper ball was dropped into the water in the container. So, if you now ask how many substances are mixed together now, it will be incorrect to say 2 substances. Water is kept in a container. You drop copper ball into water which is in the container. So how many substances are mixed together now? 3. What are the 3? Copper ball and water. Clap for yourself. Now, next question. Of these 3, which one loses? Which one gains? If you want to talk, you let me know. It's when you know this, you can solve this question correctly. The first defeat you can give to the question is how many substances are mixed together. Once you get the substances that are mixed together, the next thing is to ask yourself, what and what is losing and what is gaining. Once you're able to get that, you get the question solved. Yes, which one is losing to what? Yes.
The copper ball will lose it.
Talk louder, let them hear you in the class.
The copper ball will lose it to the water and its container.
Why do you think copper ball will lose it?
That's an temperature. Like, the temperature is.
Please clap for her. She has gotten it correctly. Copper ball will lose it to water and its container. Why does the copper ball lose it? Because it has higher temperature than water and its container. Copper ball was at 200 degrees Celsius. Water is at 30 and its container too will be at 30. So obviously copper ball will lose to water and its container. So in other words, heat lost by the copper ball will be equal to heat gained by the water and its container. And that's where the solution started. That's the physics you are going to say. After you have extracted all what you have here, the next thing to write is to say heat lost by copper ball equals heat gained by water and copper calorimeter. That's it. That's the physics there. Copper ball and copper calorimeter. Copper ball and copper calorimeter. So we now express that mathematically. To express it mathematically, we can say, how do we calculate the water heat lost by copper ball? That will be mass of copper ball, the capacity of copper. Because the ball is made up of copper. So we are making use of the capacity of copper. Then change in temperature from 30 to mixture temperature equals mass of water, the capacity of water, then change in temperature of water plus mass of, I think this one is MB. This is MB. We use MB for the ball, so we use it here. Now this is W. This will now be mass of calorimeter, the capacity of that copper, and change in temperature. I use C for copper, and the ball is made up of copper. That's why I put it as C. Now this is in marking. If you have written this, they score you here. But if you don't write this, you go straight to this, you get the same score. The score for this and this are the same. This is the physics. Every other thing you will put now is purely mathematics. This is physics that needs to be substituted correctly. Concept of physics is here. Then you substitute it correctly. You can break this one down into mass of copper ball, MB, capacity of copper, change in temperature now. This is going to drop from 200. That's initial temperature of the ball. That's I minus the mixture temperature. That's theta N. You must have indicated mixture temperature, which is actually what you are looking for. The question says you have to calculate the mixture temperature, which is final temperature, and that will be equals to mass of water, the capacity of water. Change in temperature of water will go from 30 to mixture temperature. The same thing will do happen to the container, mass of container, but before you use 30 here, you can say initial temperature of water plus mass of the copper and the calorimeter. The capacity of copper, change in temperature here will also be theta M minus theta copper I, or 1 initial. This one is still the same thing with what you have written here. Now substitution. You are having 20 grams for the mass of the ball. You put it down. 20 times specific capacity of copper. You have 0.4. Although, like I said, since it is not given in the question, you can still use C. And you will get your answer in terms of C. Now, into mixture temperature, we don't know. But we know this one was at 200 minus mixture temperature. And that will be equals to mass of water we have here. The mass of water is 50 grams. Is it written?
Yes, sir.
Okay, yes. So you have 50 grams times 4.2. Then into mixture temperature not known minus initial is 30 plus mass of calorimeter 60 times 0.4 into theta M minus 30. That's what you do. That's substitution. Every other thing is simple arithmetic. So you try to make theta M the subject of formula and simplify it. How will this happen? Of course, like I said the other time, you can write this one in fraction from decimal. If you do that, you have 4 over 10 times this. 10 will cancel this. 2 times 4 will give you 8 straight away. 8 times 200. You can say 200 minus theta M without using calculator. Then this also will give you 42 over 10. You have 0 will go. 5 times 2, 10. 5 times this, 20 plus 1. That's it. Into theta M minus 30. Reduce this to this. Then plus, reduce this one, that will be 24 into theta M minus 30. It makes it simpler than the other one. So you can go on until final answer is obtained. How? This time this is 16 minus 8 theta m equals 210 theta m minus 0036. 0 here, 3 times this, 310, you have this. Then plus 24 theta m, then minus, you add 0 to this, 3 times 4, 12. 3 times this, 6 plus 1, 7. Straight away, without calculator, you have it done. Now, collect the like terms. To collect the like terms, you can bring all theta m to this side, and that will give you minus 8 theta m minus 2, 110 theta m minus 24 theta m equals minus 6300 minus 7200 minus 16. That's it. Now, it will be easier for you to use your calculator to do this, or even if you don't want to use calculator to 4 plus 0. 4 plus 0 is 4 plus 8. That's 12. Yes. So you write 2 here, theta m. Then you add 1 to this. That's 3. 3 plus 1, 4. So you have 4 here. Then the next one is what? The next one is what? 2. I don't know why some of you are laughing. First somebody come and solve it on board and correct. Now, how do we add this? Very simple. You can arrange. If you cannot add up straight away, you can arrange them like you do in primary 4, 5. You have 0, 0, 0 here. Arrange them. Then you arrange 1, 2, 1, 2. So you have that's 2, 0. Then the third one, 6 plus 2. That gives you 8. 8 plus 3. 11. Then you write 1. You carry 1 to the fourth one. 1 plus 1. 2. Then 2 plus 7. 9 plus 6. 15. So you have minus 1, 5.
Yes.
So you now divide both sides by 242. Theta m will be equals to minus 15100 all over minus 242. What can go? Yeah, somebody will say, now how do we do it with our calculator? You eliminate. 2 can go. This is even number. 2 can go here. You have 1, 2, 1. Then 2 here. You have 7. Of course, this cancels. Then 2 in 11. That's 5. Then 5 again. 0. So you now think of what else can go. Can 11 go? No. So you can now say 7,000. So yes, 550 divided by 75050 all over 121. So what is it? Minus 720.
Yes.
So you have 720 here. Then we had. So it means 0 here, that's 1. Then you have 2 here. 0 plus 2. 2. Then plus 0. 2. Good. Then the third one. You have 6 here. 6 plus this. 13. Then 13 plus this. 16. So you write 6. Then the fourth part. You had 1 to this. That's 2. 2 plus 6. 8. You have minus 8. So, time for that observation. Now, the next one, you now divide by minus 242. Yes, and what is it? Theta m equals what? 35.62.
Degrees Celsius.
That is a mixture of final steady temperature.
5 degrees Celsius.
Is that clear?
Yeah. Degrees Celsius. 5 degrees Celsius.
It's okay. Why are you wasting our time? I want other people to learn. Raise your voice.
I think that you change the temperature of the copper ball. I think it's changed from 200 degrees Celsius to 70 degrees Celsius.
Can you hear what he's saying?
No.
The question is the ball that is at 200 degrees Celsius. When cooling, she thought it's going to cool from 200 to 70 before it come down. Is that not your question?
200 to 100 degrees Celsius.
No, it won't. If it were to steam at 200 will cool down to 100. Change of state will take place in that case. This is a copper ball, a solid ball that is heated to that temperature. So, and drop into this. It will not go to any before it come back to no. Is that clear to you? Actually, I really expect somebody to respond to that. But time is not our friend. Now, an electrical heater raises the temperature of 120 grams of water in a thin light vessel through 10 Kelvin in 2 minutes. When placed in 70 grams of water containing in a metal vessel of mass 0.55 kilogram, the temperature rises to 9 Kelvin at the same time. You have to calculate from the above the heat supply in 2 minutes by the heater. Who want to do that for us? Who want to do this one for us? When the temperature of 120 grams of water in this thin vessel change by 10 kilograms in 2 minutes, you can calculate the first one, the heat supply by the heater. Well, the supply here, we have mass of water. MW equals 120 grams. What is given below are in kilogram. Yes, kilogram. So you need to convert this one to kilogram, and that will divide by 1,000. 0.120 kilogram. That's what that would be. Then you are given you are told that it's a thin light vessel, so the thermal capacity will be very small. We are giving rise in temperature. Rise in temperature, delta theta is 10 Kelvin. That's when it is used in the water. Then the time T 2 minutes, which can be converted to 2 times 60 seconds, which is 120 seconds. Then you place it in another water. The first one, A, you can answer A part. Heat supplied. You have to calculate heat supply in 2 minutes by the heater. Let that be Q. So we are looking for this. Very simple. What do we need to do? Heat is lost by the heater. To what? To the water. In a tin, when they say tin like vessel, that vessel have very negligible thermal capacity. So we can ignore it. Now, we are going to have heat loss. Heat lost by heater will be equal to heat gain. Gain by water. So we don't consider the container because you are told that thin, light vessel. So heat loss by the heater, I give you for formula in one of the classes we had in the past. PT is equal to quantity of heat lost by the heater. And you are asked to calculate the quantity of heat lost by the heater in 2 minutes. The heat supply in 2 minutes by the heater is equal to PT, which is equal to mass of water, frequency of water, change in temperature of water. So the quantity of heat lost by this is Q, PT, and heat lost by heater equals to heat gain by the water. So heat gain by the water is determined. Once you know the heat gain by the water, you already know heat loss by the heater, which will now be the mass of water is 1.6 times 4200 times rise in temperature is 10. So you work this one out. How do we simplify this? Change it to 120 all over 1000 times 4200 times 10. 1 0 will cancel this, another one will cancel this, the last one will cancel this. So obviously we have 120 times 42 times 1. Now you can start by saying 42 times 0, that is 0. 42 times 0 is 0. 42 times 2, that is 84. You write 4, remainder 8. 42 times 1 is 42. You add 8 to that, that gives you 50. This is 50 joules. That will be the quantity of heat lost by the heater. You have to calculate heat supplied in 2 minutes by the heater. The second question says, B part, the power of the heater. The power of the heater. Very simple. Once you have known that the quantity of heat is Z, to get the power, from here we can simply say B part. We need power. Power P, not known. But you can see P equals Q all over T. And you got your Q here to be this. So it means 5040 joule all over time in 2 minutes. 2 times 60. That's it. So straight away, 0 here, we cancel this 0. You can say 2 goes here, 1. 2 goes in this, 2, 5, 2. You can still use 2. 2 goes here, 3. 2 here, 1. 2 here, 2, 6. So power can be written as, that would be 42 watts. So 2 watts can be written, or joules per second. That's the power of the heater, and that's B part. Then the C part says the heat supply to 70 grams of water. Heat supply to 70 grams of water. Now remember, you are told that the 70 grams of water is kept where? Metal vessel. It is kept in metal vessel. You are given the mass of the metal vessel. So now the heater is immersed into 70 grams of water, kept or contained in metal vessel of mass 0.55. So the temperature rise is 9 Kelvin. So you can calculate the heat supplied to that container. Then you should know that if you want to calculate the heat supply to the metal, it's simple. That's CPAN. PT equals mass of water, the capacity of water, change in temperature. And the change in temperature is now 9 to get the quantity of heat supplied to the metal. We work that out. This time around, the mass here is 70 gram. Change it to kilogram. 70, 1000 times 4. 4,200 times 9. That gives the quantity of heat supplied to 70 grams of water. And that will be worked out. You have 0 here, cancel this. 0 cancel another, this cancels this. So you now have 7 times 4, 2 times 9. So what is that? 2,646 joules of heat was supplied 24. Now, but you know this is kept in a container. So other vessel to gain part of the heat lost. So we want to now calculate that's the part. Heat supplied to the metal. Then some other things will be calculated. Heat supplied to the metal. So how do we get the heat supplied to the metal vessel? That's the part. So you can simply say PT equals mass of 70, mass of water, the capacity of water, change in temperature of water, plus mass of the metal block, metal container of vessel, the capacity of metal, change in temperature of metal. That's for T. And you already calculated the power of this to be 42. 42 times, the time is 2 minutes, 120. That will be equals to what you have calculated above. All this will be, this one will be repeated here. But to save our time, I will code the value here straight away. 2646 joules. Then plus, we are looking for the heat supplied to the metal plus the whole of this mass of metal, the quantity of metal, change in temperature. So the difference between this and this will now be heat supply to the metal. You are asked to calculate the heat supply to the metal. So the difference between the total this and this is equals to heat supply to the metal. Some of you are just busy writing. You are busy writing the solution down instead of you to learn the correction and let's do it together. Quantity of heat lost to the metal. Quantity of heat lost to the metal will be given by that. And what is that? Quantity of heat lost to the metal is given to be, the difference between the two of them is what? 2394 joules. That's the part. So you have to calculate E. Calculate the heat capacity of the vessel. Calculate the heat capacity of the vessel. How do we calculate the heat capacity of the vessel? Can someone tell me how to calculate the capacity of the vessel? How do we calculate the capacity of the vessel?
The heat lost to the vessel equals to MC change in theta.
Heat lost to the vessel
equals to MC change in theta.
MC change in theta.
Yes.
No.
Why the heat capacity is MC.
Now get the question clear. We have gotten the heat lost to the metal. How do we now calculate? How do we calculate heat capacity? We have to calculate capacity of the vessel, and we already know the heat loss to the vessel, and we know the temperature rise in the vessel. How do we calculate heat capacity? Okay, what is heat capacity, by the way? What is heat capacity? Anybody want to talk to raise up his or her hand so that we can see?
Sit down, talk. Sit down, talk.
Is the total heat required to raise the mass of a substance by 1 kg?
That's the quantity of heat required to raise the mass, to raise the temperature of a substance by 1 degree Celsius, 1 Kelvin. This is not how to prepare for JAM. Another exam you have. Are you going to read when the exam is 1 week or 2 days? All these things should have been in you. You did it before you get here, and we repeated it. It was referred to last week. And you claim it was cleared. Now it comes to applying what you have been taught. You are just looking as if it's a strange thing. This formula was given to you. It was given that Q, beginning of the class, Q can become this delta theta. It's in your notes. And I gave you, is either this, or you write Q equals C into theta 2 minus theta 1. It should be part of the first note given to you when we started this topic. That's for thermal capacity. We later move on to specific capacity, in which we said Q in that case will be given by MC delta theta. Delta theta here, or MC into theta 2 minus theta 1. It is obvious that you don't go through what you are taught. And some of you will be playing the class. We calculate specific capacity. I was expecting you to simply say, we can only get capacity by dividing the quantity of heat lost to it by the temperature rise. That means, how do we get this? We said this is heat capacity. How do we get it? Divide it by this. That's all. So, heat capacity now, capacity. That's C will be equal to Q all over theta. That's all. And that will give us 2, 3, 9, 4, 9. So simple. That's so simple. Well, I won't deceive you. If you don't have time to go over what you are taught here, you are not better than those that do not come to this program to pose problem to you. And the previous said, don't do like this. Now, what's the final answer?
266.
I can easily ask you to press calculator and tell me the answer of all this, but I want to train you that you can still work without calculator and put that into practice. If you don't have calculator, I can press calculator on my phone to get the answer out straight away. And we are doing that. Some of you are still playing. Now, what do you call the answer here?
266.
2662.
Per Kelvin.
No.
Yes, per Kelvin.
266.
Per Kelvin. So that's your state. Then the next question, which is the last one. The question is how you have to calculate specific capacity of the material, that is the metal materials, the first two materials. If I ask you a question now, you still be looking at me the way you look at the bosses. How do we now get specific capacity now? Mass times heat capacity. Mass times heat capacity.
I'm sorry, mass heat capacity as a mass.
Yeah, that's the summation. Who else wants to say something? How do we get specific capacity? Yes.
Quantity of heat divided by the product of mass and the temperature change.
That's the two of them are correct. If you have gotten heat capacity, you get specific capacity from heat by dividing it by the mass, or the quantity of heat divided by the product of mass and change in temperature. All these things. Without this question I gave to you, if you have attempted question on this heat before, you will have understood this more than this the way you are. Now, so to get this, from this expression, we call this one specific capacity. How do we get it? Divide both sides by FC. So small letter c now will be equals to Q all over M delta theta. And theta here is already calculated to be 2394 all over the mass. The mass is 0.55 times. That's how the specific capacity will be obtained. I don't know why some of you are just busy copying this. You are not contributing in the class. Next class you are giving questions you say you don't understand. Are you busy writing? Wood cup, clay pot, cup, metal cup, calorimeter, copper calorimeter. So the specific capacity of the material that is used to make that, we are talking of vessel. Here they said metal vessel. So the metal is made up of some material. It could be, the question is silent about it. It could be aluminium vessel. It could be wooden vessel. It could be plastic vessel. Whatever it is, what is the capacity of that material? Is it clear to you now? So when they say vessel is what you have used the material to mold. You can use the like copper now. You say copper ball, copper calorimeter. So specific capacity of the two of them are the same because they are made of the same material. Copper ball is different from copper calorimeter. Am I communicating? You can also have water block. The shape is not what gives specific capacity, but the material. When we say water, water can be put in any shape. The shape will not affect the specific capacity, but the material is water. Is that taken now?
Yes.
Any other question? Now let's go to question 3. Let me which one you write as question 3. Okay. Question 3. What mass of ice? What mass of ice at minus 14 degrees Celsius will be needed to cool 20 centimeter cubes of an orange drink, essentially water, from 25 degrees Celsius to 10 degrees Celsius. And you are given specific latent heat of fusion of ice to be what is given, specific capacity of ice to be what is given then the next one. Now in this case, ice block was at minus 14 degrees Celsius, isn't it?
Yes.
Good. Then you drop it into the drinks, which is orange drinks, essentially water. That means the most content of that drink is water. Essentially water. To cool it from 25 to 10 degrees Celsius. Now, the usual question is, how many substances are mixed together here? How many substances are mixed together here? This question was given to you last week. You ought to have think about the question before. Yes, how many substances are mixed together here? 2. If you want to talk, let me see your hands up. Who said 2? Yes. What are the 2? Stand up, let's know. You can talk loud.
Water and the orange drink, which is composed made of ice.
Okay.
And the orange drink, which is composed mainly of water.
Clap for him. Now, we are talking of two things. There are silence about the container here. And I told you in the beginning that when the examiner or the question is silent about a particular thing, you don't import it from anywhere and use. So in this question, the examiner did not mention the container in which the orange drink was kept. So now we are talking of two substances. Now of these two substances, which one is losing, which one is gaining? Yes? Anybody want to contribute to that? It means we have not even thought about this question at all. Yes? It's only the boys that are contributing. I don't know what happened to the girl. Yes?
The water is losing while the ice is gaining.
The water is losing while the ice is gaining. Clap for her. Then the heat gained by ice will be divided into how many parts? Two? Yes. How do we know? How do we have the two? You raise your voice so that people can learn from what you are saying.
The heat that will convert it from -14 to 0 degrees Celsius, and the one that will raise it to 10 degrees Celsius.
Okay. From -14 to 0, then it will now raise it from 0 to 10.
Degrees Celsius.
Okay. Who want to contribute to this? How many parts of heat gained by ice, or how many parts will the heat gained by ice will be divided into? Quickly, the time is gone. Yes.
3 stages.
3 stages. Can we hear the stages?
The first stage we take it from -14 degrees Celsius to ice at 0 degrees Celsius. The second stage from ice at 0 degrees Celsius to water at 0 degrees Celsius.
Right.
Third stage from water at 0 degrees Celsius to water at 10 degrees Celsius.
Please clap for him. I'm sure if you have that idea and lay hands on this question, we'll get it. Thank you. Then, inside the drink, water at 0 will now be raised to water at mixture temperature, which is 10. That's how the heat gained by the ice will be divided into. Now, all this heat comes from what? Orange drink, essentially made up of water. In other words, what you call orange drinks is mainly water. So you consider it to be water. Now, instead of, our time is gone, instead of giving you the mass, what are you giving? You are giving the volume. And below, the density of water should be given. Then, if not given, you work in terms of the density. Because it's an exercise, they may expect you to pick from the textbook the density. But if not, you work in terms of density. For you can get mass by finding the product of volume and what? Density. Don't worry. I think that will be the next topic I'll quickly rush you through. Density and pressure. Immediately we finish what we want to do. Evaporation, boiling, and what have you. So you know density and pressure because jam questions come regularly under it. So I will show you the secret of that. If you see anybody getting 300 and whatever, they must have known that topic very well and magnetism. When we get there, I will tell you the secret of the jam. Now, the volume given will multiply density. And in gram, because you are giving a liter cube, who can tell me the density of water in the class? What's the density of water? Yes?
Sit down.
1 gram per cent.
Please clap for him. 1 gram per centimeter cubed or 1,000 kilogram per meter cubed. So, of course, you need not to cram, you are expected to be given anyway. So, since you have 20 centimeter cube, you can easily convert it to mass by simply multiplying that with 1 gram per centimeter cube. So, indirectly, the mass of orange drink is 200 grams. So, heat lost by orange drink will now be equal to heat gained by the ice. And heat gained by the ice will be divided into 3. I think you can work that out now. Who cannot complete that question? So please do that. And the remaining question, I will spend few minutes on Wednesday to solve that. But my observation is, I do come before 3, but most of you will not come in time. Due, then due points. Prepare for all this. I will not do the talks next class. I will call on you to do. It doesn't have calculation, so we prepare for that. Then our next topic after that will be density and pressure, as I said. So prepare for that against next class. Any question on what we did today? Any question? All correct.